Alrighty. I'm going to do problem number 20 from chapter 23. It says, a continuous line of charge lies across the x-axis extending from x equals positive x naught to positive infinity. The line carries charge with a uniform linear charge density lambda. So the question is asking, what are the magnitude and direction of the electric field at the origin? So I'm going to draw it out here on this board, and you'll have to excuse the poor quality of the video. I'll try to avoid that glare right there. They're working down here. Of course, now I have shadow. Oh, we'll see how it works. Alright. That'll be x equals 0. We'll say that that extends to positive infinity. That's the x-axis. And we'll just say that x naught is some point right about there. So the charge starts here and it goes all the way to infinity. The origin is over here behind the charge. So it's asking for the magnitude and the direction of the electric field on this point from all of this charge. So the first thing, well, they tell you that the density is a constant, the charge density, which is normally Q over the length. In this particular circumstance, because it's continuous, we can say, I'm going to come down over here, we can say that lambda is equal to dq over some section of x. So if this is dx, dq is the charge in there, and the density, since it doesn't change, is going to be dq over dx. So that's the first thing. Now we can say dq equals lambda dx. Alright then. So we want to start focusing on this point. Now we know that the distance from the point that we're talking about, which is the origin, so just 0, to any point on this charged axis here is simply going to be the value of x at that point. So right here it's whatever the value of x naught is. That's the distance from 0 to x naught. If there's some point right here, some random point, you know, x equals whatever, that's going to be the distance from 0 to that point. So if we're talking about the electric field, and we say that it's equal to Coulomb's constant times, well, I guess I'll just say dq. I'll just get right to it, save time. Normally it's over r squared. R is the distance from the particle that we're talking about to the charge, the axis of charge. So that's over r. We know r is going to be equal to x, so I guess I'll just erase that and make it an x squared. And then we know that dq is defined in terms of x over there with lambda dx. So now everything's in terms of x. Now we can bring out the constants, Coulomb's constant and the density, and we take the integral of simply 1 over x squared dx. And we're going to integrate this over the entire area of charge. So it starts at x naught and it ends at infinity. Now, we're going to move down here to a different area. And what I'm going to do here is say that this whole thing here is going to be, it's an improper integral. So, well, we'll keep the constants. Oops, here we go. I guess I'll come up from this angle. So those are the constants. They're going to be times the limit. And we'll say infinity is now going here. T is going to infinity. So we're going to restate that from x naught to t, 1 over x squared dx. So we know that that's going to be equal to those constants again, the limit, as t goes to infinity. And I'll actually just integrate it now, and I'll put it all together. It's going to end up being negative 1 over t plus 1 over x naught. Okay? So the limit here, if t is going to infinity, then this whole thing is just going to be 0. So the limit ends up equaling 1 over x naught. So basically, we're taking the constants here, there we go, and multiplying it by that limit, which, like I said, is 1 over x naught, so it's just over x naught, right like that. And that is the answer. The electric field, the magnitude of the electric field is Coulomb's constant times the charge density over x naught. And the direction that it's going, because we can see it doesn't tell us what the charge is. It doesn't tell us what all this charge is, so I guess we're assuming that it's positive. I'm going to assume it's positive anyway, and obviously I'm going to say the test charge is positive too, so the electric field is going to be going in this direction, same direction as the electrical force. And that's it. Coulomb's constant times the density over x naught going that direction. Okay.